What exactly is the problem about carbon dioxide gas? We know that it is not toxic. Right now, as you sit, you are exhaling carbon dioxide and you're adding carbon dioxide to the air around you and the atmosphere. I am too. Carbon dioxide is not an air pollutant. However, what it does is that it goes into the atmosphere, and we'll look at the molecule shape, and that molecule shape of carbon dioxide can trap heat. It can absorb heat that's coming from the sun, radiation from the sun, as infrared. So we'll get into the details of that, but in short, carbon dioxide is produced in reactions, combustion reactions like fires, or combustion reactions that are metabolizing sugars, or in coal-fired power plants where coal is burned. All of these are examples where carbon dioxide is produced in a chemical reaction. Earth is a specific distance from the sun, and it has been for 4.5 billion years. So an energy balance was established as Earth evolved from the beginning of the universe. And in order to maintain this balance that was established, all this radiation that comes from the sun and it is absorbed from the sun, all that radiation must eventually go back out into space. Okay, so this is radiation coming to Earth, but is eventually going back out to space, but not right away. So sunlight brings energy to Earth as UV, visible, and infrared. Some is absorbed by Earth, 46, and some is absorbed by Earth's atmosphere, 23. Okay, some is reflected out, so reflected from the atmosphere or reflected off the surface of Earth, and this is reflected out as a different type of energy, and this is why it's blue instead of yellow. Okay, so this is not the same as the sun sends UV, visible, and infrared. The Earth doesn't send back out visible light. Okay, the Earth sends back out infrared heat, and so some of this heat, infrared, is absorbed back in the atmosphere, while some of it is emitted from the surface or emitted out to space from the atmosphere. But this, let's focus on the 30%, 37% that is absorbed in the atmosphere. That's actually important because having some of this heat retained in the atmosphere, in this envelope that is encircling Earth, that allows for Earth to be warmer than it would be. If all the infrared heat that we receive from sun, if it were all sent back out, temperature would be about negative 18 degrees Celsius. This would be worldwide over all countries and throughout the year. The average temperature would be negative 18 degrees Celsius or about 0 degrees Fahrenheit. And that would mean a year-round freeze on average. So what has been established is not a year-round freeze, which we know, but that thanks to the heat that is absorbed and trapped in the atmosphere by atmospheric gases, about 80% of the heat is capped that would be sent back out. So that's important because therefore Earth's atmosphere keeps the troposphere where we live a habitable temperature, about 15 degrees Celsius or about 60 degrees Fahrenheit average worldwide and over the year. So this is important because that's how Earth has evolved, that the average temperatures evolved as the Earth evolved and as life evolved on Earth, and that's what we know how to handle as well as all the living things on Earth. So how does this absorption happen? Well, in the atmosphere, there are gases that trap and return a major portion of the heat that would be lost to space, and this is called the greenhouse effect. The greenhouse effect keeps the planet warm, warmer than it would be without it, and it's a natural and necessary process. So if you hear about the greenhouse effect being a problem, the actual problem is the enhanced greenhouse effect that traps more than 80% of the heat in our atmosphere, and that's what we're experiencing now. So here's a summary of the greenhouse effect, which is like a greenhouse for plants, where you have radiant energy coming in and being stored or trapped inside of the greenhouse, keeping the plants warm, and that's the same is true for the Earth. That most of the heat that is trapped in the atmosphere is good. We need that. Otherwise, we would lose all that heat. And so it's a natural and necessary process, and it's thanks to the gases in our atmosphere. So the issue becomes the enhanced greenhouse effect, where there's the same gases in the atmosphere that have been present are increasing and trapping more of the heat because that's what they did to begin with. So now there's more warming, and this is a question. So the number one gas of the atmospheric gases that traps heat is carbon dioxide, though it's not the only one. And what we have for comparison is Venus. So the atmosphere of Venus is about 96% carbon dioxide. Venus is a pretty desolate planet. There's no life on there. The atmosphere is not only different, but there's a large 90 times greater air pressure, and the clouds are made out of sulfur dioxide, and so that's smog. So talk about some serious air issues there. The surface is desolate, it's eroded, there's nothing living on there. The average temperatures are from this atmospheric carbon dioxide trapping heat on Venus, the average temperatures on Venus are about 840 degrees Fahrenheit. And that is due to the trapping of heat on the Venus's surface from the atmospheric carbon dioxide. That's what this molecule does, and we'll look at the shapes. So on Earth, our atmosphere is less than 1% atmospheric carbon dioxide, so about 400 parts per million, which is higher than it's ever been in about 1 million years. Now that's a good thing when we're talking about the greenhouse effect, but the enhanced greenhouse effect, where we're trapping more than the 80% of heat, is causing temperatures warmer, and this is the direction, is when it's known that when there's more carbon dioxide, it gets warm. So that's the direction, the general direction of Earth's atmosphere, more carbon dioxide, warmer. So the initial issue was named global warming, and it is the subject of this week's discussion post. And so that global warming moniker has actually since been dropped. It's still around, but the idea is that it is actually not even. It's not an even warming, and it doesn't actually describe the true problem. Climate change is a better way to describe it, and I think I've used this term already. It's actually everything that's going to change. So we'll get to that. But first, let's look at the data.